Hello students, in this video we are going to see the problems on homogeneous differential equation. In the previous video we have seen the introduction of higher order differential equations and what is homogeneous and what is non-homogeneous differential equations. Now let us consider the first topic. If we consider all these list of topics, we are in the first topic, homogeneous linear differential equations. So what is a homogeneous differential equation? If f of d is equals to 0, then that is called f of dy is equal to 0. Then that is called homogeneous differential equation. Okay, let us see the first problem, how to solve the homogeneous differential equations. Okay, now the given question is solve d cube y by dx cube minus 9 into d square y by dx square plus 23 dy by dx minus 15y is equal to 0. Here we have to consider few things about this differential equation. So if you see this one, this is a differential equation of order 3. This is a differential equation of order 3. That means it is a higher order differential equation. And second thing, see the coefficients. Anyway, the first higher order differential equation coefficient will be definitely 1. The remaining minus 9 plus 23 minus 15, the coefficients all are constants. So this is a higher order differential equation with the constant coefficients. And third thing, we consider the right hand side is 0. If the right hand side is 0, that is called homogeneous linear differential equation with constant coefficients. Okay, and we have seen in the last video, we have seen how to write operator D form. So how do you write operator D form? D cube y by dx cube is nothing but d cube y. We take y as common in all the terms, and minus 9 into d square by dx square can be written as d square y, and 23 dy by dx can be written as 23d into y minus 15y. So y common, and right hand side anyway 0 because it is a homogeneous differential equation. Okay, and here first step. So we have seen in the previous video how to solve the homogeneous differential equation. The first step is to write the operator D form. Okay, and next mostly they give you operator D form only. Rare cases you get questions like this. Okay, and next is the second step is to write the auxiliary equation. How do you write the auxiliary equation? Just we ignore y and we take the only the polynomial in d, and in place of d we put m. That is what is the auxiliary equation. By seeing it, we can say that m cube minus 9m square plus 23m minus 15 is equal to 0. Just we ignore y also. Okay, so m cube minus 9m square plus 23m minus 15 is equal to 0. So we can find this is, since it is a polynomial of order 3, okay, polynomial of degree 3. So we find 3 roots. What is the 3 roots? M is equal to 1, 3, 5. We can find the roots using calculators or some other methods. You can find it. Okay. And here, this problem comes under which case? In the previous video, we have seen the 5 cases. The first one is real and distinct. Second one is first 2 roots are equal and real. And third case, first 3 roots are equal and real. Fourth case is complex conjugates. Fifth case is equal complex conjugates, and remaining distinct. Okay. Out of all these cases, 1, 3, 5 means distinct roots. Since these are the distinct roots, the general solution is, here we consider, see, since it is a homogeneous equation, the general solution will be y is equal to yc only. There won't be yp. Yp is 0. Okay. And since the roots are real and distinct, what do you write? C1 into e power m1x. Here the power is the first root. What's the first root? 1 plus c2 into e power m2x. What is m2? The second root. What's the second root? 3. And c3 into e power m3x. Third root. What is the third root? 5x. So e power 5x. We substitute only 3 roots. Remaining everything is same. Okay. So this comes under first case, real and distinct. So let us move to the second problem. D cube y by dx cube minus 3 dy by dx plus 2y is equal to 0. So first step. What's the first step? We have to write in the operator D form. D cube y by dx cube can be written as d cube, and minus 3 d by dx as minus 3d plus 2 and y common. This is the first step, is to write the auxiliary, is what you call operator D form. Second step is to write the auxiliary equation. What's the auxiliary equation? So we consider only this polynomial. We ignore y. So what's the polynomial? M cube minus 3m plus 2. In the place of d, we substitute m. And third step is to find the roots. So based on these m cube minus 3m plus 2, we can find in any method, we can find the roots using calculator also we can find. So 1 comma 1 comma minus 2. So this problem comes under which case? Second case. What is the second case? First two roots are equal. If the first two roots are equal, so we write what? C1 in C1 plus C2x into e power m1x, where m1 is the equal root. What's the equal root here in this case? 1. So in the place of m1, we put 1. So C1 plus C2x into e power 1x, here m1x. The remaining root is, since it is distinct, we write C3 into e power m3x. What is m3? Nothing but third root m minus 2. Okay. So suppose you may be thinking that if I take the roots as minus 2, 1 comma 1. Suppose if I write minus 2 at starting and 1, 1, second root, third root. Suppose minus 2 is the first root. Since it is distinct, we can write C1 into e power minus 2x. And the second and third roots are equal. Suppose if I write the end. So that is C2 plus C3x into e power that m2, that is equal root m1 1x. So we can write the solution in this form or in this form. So both the forms. If we write the roots as 1 comma 1 comma minus 2, this is the solution. If we write the roots as minus 2 comma 1 comma 1, this is the solution. Both are same, so no need to confuse. Okay, that's the second problem. We have seen two problems in two cases. Okay, let's move to the third problem. The third problem is given by, so see here, it is already in the operator D form. Maximum in the exam also you get operator D form only. Rare cases you get in the D square by dx square form. Okay, it's already in the what you call operator D form. And directly we move to the second step. What is the second step? Writing the auxiliary equation. How do you write the auxiliary equation? Just in the place of D, put m. So what do you get? M power 4 minus 2m cube minus 3m square plus 4m plus 4 is equals to 0. Just we ignore y. Okay. So we get this one. Since it is a fourth order, we can find using calculator. Fourth order also, some calculators we get it. Class with subject fx9n1 ex version, we can find 4 roots. Anyway, here it's a trial and error method. Using the trial and error method, first we substitute 0. 0 is not the root. And if we substitute 0 here, so what do we get here? One second, I'll explain here. The equation is m power 4 minus 2m cube, m power 4 minus 2m cube minus 3m square minus 3m square plus 4m plus 4m plus 4 is equals to 0. Next, first of all, if you substitute 0 here, 0, 0, 0, 0, 4. The answer is 4. Okay. Suppose if I substitute 1. So like this, in the trial and error method, we substitute 1, 0, minus 1, 1, minus 2, 2. Like this, we substitute 1 by 1. 0 is not the root, trial and error method. Now we substitute minus 1. Suppose if we substitute minus 1, minus 1 power 4. That's nothing but plus 1. So I'll write only plus 1 here, plus 1, plus 2, because m cube is minus 1 cube is minus 1. Minus 1 into minus 2, plus 2. Here, minus 3. Minus 3 into 1 minus 1 square is plus 1. Plus, here we get minus 4, because m is minus 1. Plus 4. Okay, here what do we get here? Minus 4 plus 4 gets cancelled. 1 plus 2 is 3 and minus 3 cancels. So the answer is 0. So minus 1 is the solution. Minus 1 is one of the root. So like this we find the real, what do you call, trial and error, using trial and error method. Suppose minus 1 also, if we won't get any, we won't get 0 here. If it is non-zero, we try 1. If it is not, 1 is not the root, we try 2. Like this, 0, minus 1, plus 1, 2, minus 2, like this trial and error method. Once if we find one root, so put it here minus 1. This is called a synthetic division. We have learned in school levels only. But again, I'm explaining. Okay. Here we write the coefficients of this one. 1, minus 2, minus 3, 4, 4. So here 1, minus 2, minus 3, 4, 4. And first of all, here we write 0. Actually, it's not 1, actually 0. Okay. So this is only the mistake. 0. 1 plus 0 is 1. Always we put here 0. Okay. 1 plus 0 is equals to 1. 1 into minus 1 is minus 1. Minus 2 minus 1 is minus 3. Minus 3 into minus 1 is plus 3. Minus 3 plus 3 is 0. 0 into minus 1 is 0. 4 plus 0 is 4. 4 into minus 1 is minus 4. And 4 minus 4 is 0. Always we get at the end 0 only. If we won't get 0, then this one is not the root. If we won't get 0. Okay. So if 1 is the root, minus 1 is the root, m is equal to minus 1. What is m is equal to minus 1? M plus 1 into, so we write this one. How do you write this one? These are the coefficients. M cube minus 3m square. See here, m cube minus 3m square. Like this we get it. Plus 0 into m. So m part is not there. M term is not there. So plus 4. Plus 4 is equal to 0. Like this we write. And like this, after reducing it to third order, we can find the roots. Okay. Whenever we find the roots in calculators, this one, we get a minus 1, 2. Only in the calculator, we get only minus 1, 2. So second one will be repeated. So we get minus 1, 2, 2. Here, this problem comes under repeated roots. Roots repeated and 2 times. Okay. So minus 1, minus 1. If minus 1 is repeated 2 times, what do you write? C1 plus C2x into e power the repeated root minus 1x. Next, as well as 2 also repeated. So we write C3 plus C4x into e power the repeated root x. Repeated root 2 into x. So that's the complementary function. For homogeneous, complementary function itself is the general solution. There is no particular integral. So we learn particular integral later. So just as of now, we learn only complementary function. Okay. And let us see, let us move to the fourth problem. Solve d square y by dx square plus dy by dx plus y is equal to 0. Here we write in the operated d form. As usual, d square plus d plus 1 is y is equal to 0. This is the first step. Second step, we consider only the polynomial. We ignore y. So m square plus m plus 1 is equal to 0. In the place of d, we substitute. Yeah. And we can find the roots using any one of the methods. Here also we can find minus b plus or minus square root of b square minus 4ac by 2a form. So we have learned in school levels. So minus b plus or minus b square minus 4ac by 2a. Using this also we can find the roots. Otherwise we can also use what do you call using calculators. And here, what's the real part? Minus 1 by 2. Imaginary part? Root 3 by 2. So here we got complex conjugates. What's the complex conjugate case? Fourth case. Under the fourth case, what is the complementary function? C1 into cos bx. 3 substitutions I told you. 1, root 3, root 3. So C1 into cos bx plus C2 into sin bx. In the place of b, we substitute the imaginary part. Root 3 by 2, root 3 by 2. Remaining everything is same in every problem. Okay. If you get the complex roots. And e power, the real part. What's the real part? Minus 1 by 2x. So we substitute only 3 things. 2 times b and 1 time a. A is minus 1 by 2. B is root 3 by 2. Like this we write the complementary function if the roots are conjugates, complex conjugates. Okay. Let us move to the next problem. So solve, it is already in the operator d form. See, d power 4 plus 8m square plus 16y is equal to 0. Okay. And the second step is to write. So the first step is we can skip it because it is already given in the operator d form. Directly we move to the second step. What's the second step? Auxiliary equation. What's the auxiliary equation? M power 4 plus 8m square plus 16 is equal to 0. Just we ignore y. Okay. And next here, m power 4. So power 4. If the powers are even, that is we got only 4, 2. If we get only even powers, we can simply solve that d square. That is m square is equal to x. If you substitute m square is equal to what do you get? M square is nothing but x. X square plus 8x plus 16. X square plus 8x plus 16. So the degree 4, the polynomial of degree 4 is reduced to quadratic equation. The quadratic equation, we can find the roots very easily. We get minus 4 as the root. Here, minus 4 comma minus 4. We get minus 4 comma minus 4. So that is x is equals to minus 4 comma minus 4. What is x? Nothing but m square. M square is minus 4 comma minus 4. So what is m roots? minus 4 under square root, comma, minus 4 under square root. So minus 4 under square root is plus or minus 2i, and minus 4 under square root is plus or minus 2i. So we got equal complex conjugates, okay? So that is, here the roots are plus or minus 2i repeated 2 times. Here we treat it as 0 plus or minus 2a. The real part is not there. What is the real part? A is equal to 0. Imaginary part is 2. So how do you write the solution? Simply C1 plus C2x into cos bx. What is b value? 2. The imaginary. So the imaginary part 2. Next plus C3 plus C4x into sin bx. What is b value? 2. So bx whole into e power 0x. What is e power 0x? 1. That's why I have not written the exponential form. So no need to write if the real part is not there. So this we have done using the fifth case. It's already there here. C1 plus C2x into cos bx. Here in this case, b is 2. C3 plus C4x into sin bx. Here b is 2. Into whole into e power ax. What is a value? 0. That's why e power 0 is nothing but 1. That's why I have not written in the solution. Okay. So let us see the answer. Fifth question answer is this one. Okay. So like this, we can find the complementary functions. No need to practice complementary function more problems, because in every topic in this unit, we get the complementary functions. YC, we have to find YC definitely. Okay. So if you observe all these topics, first starting onwards, homogeneous, non-homogeneous, also we need YC. Legenders and cautious also we need YC. Method of variation, but in every like this, in every topic we need complementary functions, YC. Okay, so we can practice them later. So in every topic, as we can do, and we can practice more problems on complementary functions. Okay, and in the next video, this is about the homogeneous differential equations. The next topic is non-homogeneous. Before learning non-homogeneous, we have to learn something, some operators and something. Okay, so we shall see later in the next video. Okay.